In this lesson, we're going to be talking about slope rate of change application problems. Let's go ahead and take a look at this first one. Customers of a satellite dish company must pay for installation of the dish and a monthly fee for service. After 6 months, Jack had paid $594. After 11 months, he had paid $989. Here we want to write and solve a linear equation to find how much it will cost for the installation. Then we want to ask, how much will 2 years of service cost? So let's go ahead and begin this by talking about the variables in this problem. There are 2 variables in this problem that we're talking about, and those variables are months and the money that we have to pay, or Jack has to pay. So let's go ahead and indicate that first by writing that our X variable is going to represent the months, and the variable Y is going to represent the money that is paid. Okay, you'll notice that in this problem, there's a very important sentence here, and it's this sentence. After 6 months, Jack had paid $594, and after 11 months, he had paid $989. Those are actually 2 coordinates. Here's what I mean. I'm going to write that down as 6, comma, 594, because that's 6 months, and then he paid $594. And then the other coordinate is going to be 11 months and $989. We're going to use those coordinates to help us figure out what this linear equation is. So think about what we've learned in this unit and think about how we can construct a linear equation given 2 points. So there's a couple different ways. I'm going to go ahead and start by using our slope formula. Remember, our slope formula, we are going to relabel these as x1, y1 and x2, y2. And let's go ahead and determine the slope. M equals, so we have 989 minus 594 divided by 11 minus 6. And if we simplify that down, that will simplify to 395 over 5, which simplifies to 79. This represents our slope of our line. Now, that's not the answer, that's just the slope. Now we have to think about, well, how have we been constructing an equation of a line given 2 points? Well, there's 2 ways we could go. We could pop this into our slope-intercept form, or we could pop this into our point-slope form, and then simplify it down to slope-intercept. So let's go ahead and put it into point-slope, since we have 2 points and we have a slope. So I'm going to go ahead and do that. I'm going to say y minus, I'm going to go ahead and use this first point over here. Y minus 594 equals my slope, which is 79, times x minus 6. That's point slope form. And let's go ahead and simplify this and put it into slope intercept form. So y minus 594, I'm going to go ahead and distribute 79x minus 474. Notice how our numbers are a little bit bigger here. I'm going to add 594 to both sides to give me y is equal to 79x plus 120. So this is the equation of the line that we're creating, because if you think about it, as long as nothing changes about the service that Jack is getting from the satellite dish company, this should create a linear equation. So the more months that he uses the service, the more money he has to pay. And it should be in a nice linear format as long as nothing changes with that installation or service. Okay, so now that we have our linear equation here, it says write and solve a linear equation to find how much it will cost for the installation. Well, this is how much it's going to cost for the installation here. And let's go ahead now and talk about, well, how much will 2 years of service cost? Well, let's figure that out. Remember, X represents months, right? So we're going to take our equation here And we're going to substitute 2 years into our equation. And think about 2 years. Doesn't that represent 24 months? So let's go ahead and substitute that in. 79 times 24 plus 120. We can simplify that down further using our calculators. 1,896 plus 120, and that gives us $2,016. So 2 years of service should cost about that much for the satellite dish to be installed in his house. That's just one way to use rate of change and slope in an application of like a real world situation. Let's go ahead and take a look at another example. In this next example, we're going to focus on using slope-intercept form. In the last example, we used the slope formula to help us out. Now let's look here. The late fee for library books is $2 plus 15 cents each day for a book that is late. If Monica's late fee is $2.75, write and solve a linear equation to find how many days late her book is. Well, let's go ahead and start by defining our variables. X is going to represent the number of days, and Y is going to represent the amount of money or the late fee. And let's think about what we have here. They give us in the problem that the late fee for the library book is $2. That's how much it is. Plus an additional 15 cents each day. That's really important. So in this problem, what this is saying is that the number that is not changing is $2. No matter what, you have to pay a late fee of $2. Sometimes we like to call that like a flat fee, meaning you have to pay it no matter what. But the number that's changing is the 15 cents because depending on how long or how many days it takes Monica to get that book back to the library, it's going to cost her. So if thinking about a linear equation, remember y equals mx plus b. The number that is going to stay the same and is not going to change is the y-intercept. That's going to be our $2. And then our slope is going to be the number that's changing. And that's going to be 15 cents. So let's go ahead and create this equation. Y equals 0.15x plus $2. And the question here, that's our linear equation, but the question here is asking if Monica's late fee is $2.75. We want to write and solve a linear equation to find out how many days late her book was. Well, remember the variables here. Think about it. The y represents the late fee. So if her late fee is $2.75, let's go ahead and solve for x because that will tell us how many days she was late returning her book. So I'm going to go ahead and just solve this linear equation here. That's going to give me 0.75 is equal to 0.15x. I'm going to divide both sides by 0.15, giving me x is equal to 5. And in our case, 5 days. So her book was 5 days late. So that's an example of an application using slope-intercept form. Let's try another one. In this example, I'm going to show you how to use point slope form of a linear equation. So at Lake Anne, it costs $10 per hour to rent a canoe. Nick and his friends rented a canoe for 3 hours and paid $45. Write and solve a linear equation to find the cost to rent the canoe for 8 hours. So let's go ahead and think about this one. Let's define our variables. X is going to represent our time, which is hours. And y is going to represent the cost to rent, we'll say a canoe. So that's our money. Okay, having that said, think about what else we have in this problem. Don't we have a point and a slope, right? Because looky here, it costs $10 per hour. Per hour. That number is going to change depending on how many hours they canoe. So that's going to represent our slope. And they do give us a coordinate here. If you look at it very closely, 3 hours, they pay $45. So that's 3 hours. They're going to pay $45. Let's go ahead and use that information into our point slope formula. So here we go. Y minus 45 is equal to 10 times x minus 3. And of course, let's go ahead and put that into slope-intercept form. Y minus 45 is equal to 10x minus 30. And I'm just simplifying this down to put it into my slope-intercept form. Y equals 10x plus 15. Okay, so now that we have this equation all set up, we can answer the question. It says here, write and solve a linear equation to find the cost to rent the canoe for 8 hours. Well, we know that x represents hours, so let's go ahead and substitute 8 in for our x. We can use the equation to determine how much we're going to end up spending. So y equals 80 plus 15, and that'll simplify down to y is equal to 95. And we're talking in terms of money because y represents the cost to rent the canoe. So that's another way that you can take a problem like this and use your point slope form of a linear equation to help you solve it. All right, you're probably thinking, well, what about standard form? Well, let's take a look at an example of standard form. Okay, a roadside vegetable stand sells pumpkins for $5 each and tomatoes for $3 each. The total sales on a certain day was $98. If they sold 10 pumpkins, write and solve a linear equation to find the number of tomatoes sold. So let's think about this. We're going to go ahead and set this up using standard form just because this problem kind of calls for it. Let's go ahead and define our variables. X is going to represent our pumpkins, or the number of pumpkins, and Y is going to represent the number of tomatoes. And you can see in that first sentence here that the vegetable stand sells pumpkins for $5 each and tomatoes for $3 each. And their total sales was $98. So let's go ahead and set that up as an equation. 5 pumpkins plus 3 tomatoes equals $98, right? Depending on how many pumpkins they sell and depending on how many tomatoes they sell, they're going to make $98. Well, if that's the case, and they tell us if they sold 10 pumpkins, let's go ahead and substitute 10 in for our X because that represents our pumpkins. And then we can figure out how many tomatoes that is. So that will simplify down to 50 plus 3y is equal to 98. And then let's just simplify it down. Let's subtract 50 from both sides. We're just kind of manipulating this problem. Divide by 3. Y is equal to 16. And we're talking about, the question asked us, what are the number of tomatoes? So this would be 16 tomatoes. See how we can use linear equations to help us we can use these application problems and we can use our understanding of linear equations to help us figure out missing pieces. That's what this is for. All right, that brings us to the end of our section on linear equation applications.